Welcome everybody. Today we're going to be talking about what is a buffer overflow. In order to start, we're going to revisit what was covered in the last video of what is a stack. Now, a stack is a data structure that puts elements on top of one another and accesses them through methods such as push and pop. So the best way to think of a stack in a brief overview is a stack of paper. Imagine you have a stack of paper and you are setting them down on a table one by one. The first piece of paper that you set down will be at the bottom of the stack, and as you put the second piece of paper down, it will be the second piece of paper, and the third will be at the top of the stack. Now, in order to get back down, you must take each piece of paper off individually. So, in order to access one, you'll have to take off three, take off two, and you will finally be back at one. And that is important. These push-pop methods are very important for buffer overflows and stack management in general. But let's get into some actual coding for right now. So this is a very basic function that just has three local variables that it puts onto the stack. And now notice we have an SP and a BP, and we will go over what this is in just a second. Now, these SP and BP stand for stack pointer and base pointer. Base pointers and stack pointers are very useful in finding out the size of what the stack will be, as the base always points to the bottom, and the stack grows, or the stack pointer also grows as the stack grows. Now, for this simple example, we will be using int size 4 for 32-bit system. So, at the very bottom of the stack, we will go one by one. So as the function is called, it will allocate local 1, local 2, and then local 3. And so, from the base pointer, we'll have OXO, OX4, and OX8. And now there are different ways to index these local variables. You could do what the variable at BP would just be local 1. The variable at BP minus 4 would be local 2. The variable local 3 would be at BP minus 8, or you could just do it based off stack pointer plus 4, stack pointer plus 8, all of that. And for this will come into a special case in arrays. Now arrays are mostly used for characters or strings in languages such as C. And let's take this array right here. Remember that arrays have a fixed size unless you resize them, and so anything put after that will be put either into the next variable or will just be terminated and truncated. So in this array, index 0 has 0, 1 has 1, and so on. And so let's assume it starts at memory address 0. 0, 0, 1, 1, and so on until we get to 5. Now what would be at 6? It would be the beginning of the next variable on the stack, which is very important. So let's finally get into some hacking over here. So we have a very basic password check right here. This password check doesn't take in any arguments. It has an integer input, an integer password. It asks the user what is the password, and it reads into the input, and then it checks the password. But notice that the if statement right here does not actually check the user's input. It checks password. But you now may be thinking, how can you check, or how can you change password if it's not something that's read into by the user? And that is where we get into buffer overflows. So, assuming that this is being allocated, let's look at the base pointer. The base pointer would have input first at 0 and password at 4, because they're both integers, still size 4. But the most important part is notice that this is reading 8 bytes. It's reading 8 bytes, which means that the first 4 bytes will go into input, and the next 4 will overwrite all of password. Because in this, similar to this case up here, if you put in more than the buffer can handle or more than the data size can handle, it will overwrite whatever is on top of it, or whatever the beginning of the next variable is. So, in order to execute something like a buffer overflow, you could use stack pointer, you could use the stack pointer and base pointer to calculate the offset size. And so, in this case, you know that password is at 0x4, and you know that input is at 0x0, and so you only need an offset of 4. Now that means you can put in 4 of any character you want, and then the next 4 characters will overwrite all of password. And so an input such as 00001234 will break it, and this will cause the shell that you want to run. And that is a very basic overview of buffer overflows. Thank you all.